All right. So welcome to week 2 of our data science boot camp. And of course, we're working on exploratory data analysis. And last week, we started with just an example, a warm up, and we're going to continue this week with that warm up. So you might be wondering, well, where are the files? How do I grab, the data file? If you don't have the data file, remember last time under class 1 of the course, we downloaded the family budget data set. Now, if you're working on your own computer, you probably still have access to that. So we will be working with the family budget CSV file. If you have to download it again from OpenHub, you're going to go to class 1 because I didn't upload it again. We don't need to at this point. And you want to download the zip file and then unzip it. The other thing is in your Google account, you should have access to the notebook that we started. All right. And you're in a minute, I'm going to show you how to open it up in Google Colab. Okay. So one thing to remember is whenever you go into Google Drive, you have access to all the software that Google Drive offers. So that's a great way to go in and open a particular document in a specific software. All right. So the reason we're doing the warm up is I wanted to make sure everyone felt comfortable before we, dove into the Airbnb example. There's a lot of really good tips and tricks and techniques that we're demonstrating. The other thing is it allows you to work on the homework in a modular way, kind of step by step. So speaking of homework, how many of you felt comfortable with the homework as you started working on it? Is everyone good? Yeah. Okay. All right. So the data set, of course, is about penguins, totally different than our family budget. But data is data, right? We have to be prepared to work with any data set that gets thrown at us, good, bad, or ugly, right? If the data has a lot of problems in it, it needs to be fixed. Now, in the Airbnb example that we're going to be doing, hopefully we get started tonight with that example. Once we get done with the family budget, there's a lot of data that needs to be fixed. Okay. So you're going to see some examples tonight. And so what I want everyone to do, first of all, just another reminder, if you came in on Zoom, make sure you put your name in the chat so we have your attendance logged. And I'm going to go ahead and share my screen. And what you're about to see should look familiar. Should look familiar. So basically, we have our family budget warm up that we started last week. Okay. So what I want you to do first is log into your Google Drive where you were last week. And it may look a little bit like a folder, right, of stuff. Now I have my stuff everywhere here. So basically, I know where this file is, and it's this one right here. I'm just going to right click on it, go to open with, and Google Colab. Okay. And that opens up the file. I already have it open, so I'm just going to go back to that. All right. So when everyone gets the notebook open, let me know. All right. And a quick question I need to ask is, does everybody have access to the data set as a CSV file? Is there anyone that needs to download it from OpenHub again? You shouldn't have to, but remember the way we uploaded our data to Google Colab last time, it does not stay in memory. When the session ends, the data goes away. So we have to re-upload it. So I'm going to show you that now. The first thing we want to do, and if anyone is struggling getting their notebook open, please let me know so I don't go too fast for you. Does everyone have their notebook open? Hopefully, want to give me maybe a thumbs up or a high five. Good, good. Classroom's good. Everyone's good, getting there, getting there. All right, we've got a couple thumbs up over here. Anyone stuck on getting their notebook open before I go to the next step? I don't want to go too fast. All right. So you can see my screen here. And remember, last week we uploaded our data file. Now there's two icons on the left, the one directly under the word called files. Now, if you don't see that, if it looks like so, let's say you don't have that expanded view, you see this little folder down here. I'm going to click on that little folder, and now I have that that navigation bar here. And what I want to do is click on the button that's directly under the word files. It looks like a little page, if you will, with a black arrow on it. And when I do that, I can then browse to where my family budget CSV file is. Okay, so, and it will give you a warning saying that your data, your runtime files will be deleted when it cancels. That's okay. We're working in this particular method because this is one of many ways to upload data. So I'm showing you the easiest way first. Okay. So once you upload your family budget CSV file, you should see it here on the left-hand side. Now, what's really important is you should see hopefully just this and maybe another folder like sample data or whatever you have. Make sure that it's, and we'll know if it didn't upload in the right location. So no worries there. Okay. Is everyone able to upload? Anybody stuck? Everyone's good. I love it. I love it. It sounds like everyone has been getting some great experience in classes, so that's wonderful. So I'm going to show you a trick. Now, if you remember last time, we got so far all the way up to our box plot. Remember the box plot with the whiskers, right? And so this is how far we got in our file, and that's okay. Now, we could execute every cell individually, one by one. But what we're going to do is we're going to execute them all and get caught up, as it were, to where we left off. Okay. And the way that you do that is you go up to, and again, you want to make sure that you can see your data file before you do this. You want to click on the runtime menu and click on run all. And what that's going to do is it's going to run each cell. And as it succeeds, you'll see a little green check mark next to it. See how I have little green check marks? If it found your data, you're going to have a little green check mark next to that import data cell, right? And it's going to keep going. And you're looking for green check marks to make sure everything ran good, right? And it should go all the way up to the box plot that we did. Okay. Anybody stuck? Okay.
Oh, I see. So DM is not declared, that's why.
Okay, I think.
Yes? Funmi, is that you?
Yes, I think. Can you just repeat how you want us to run all again?
Oh, yes, absolutely. So once you know your data file was uploaded, you're going to go up to the runtime menu and you're going to click run all. And what it's going to do is run all the cells in your notebook. Do you see that on your on the menu there?
I'm still looking. I'm
Do you
gonna
want to share your
check.
screen?
Oh, okay, yes, sure.
Yes, yeah. Okay, I'm going to stop sharing and you go ahead and share your screen. Let's see what you have. And remember, the share's at the bottom of the screen there. It looks like a little, it's a green icon, yeah.
Yeah.
Okay. So
there's so
now
many stuff opened. I don't even.
I see that. Okay. So go back to, can you, you've got penguins there. So we're not working with the penguins.
Yeah, we're working with the family budget.
Yes, you're right.
So,
So scroll up to the top. All right. And what you want to do is click on, and this happened, remember last time?
yes.
Yes. So go to content, the third folder.
Oh, yeah. 1, 2, 3. This one?
No,
No,
no.
that's
Under bin, then boot, then
okay.
content. Yeah,
Contact.
click on that. There
Okay.
you go. Yeah. So that, remember, that's where your file has to be. Remember last time you drug that from the bottom?
Yes.
So go
Yes.
down and grab your family budget file. And remember how you dragged it up and you put it in that other folder? And you did such
Mm-hmm.
a good job. Oh my gosh, there she goes again. Keep going, keep going. It'll go. There you go. There you go. Now you just want
Oh,
to put it right in the sample. Keep going. Keep
okay.
it going. Go right up into, there you go, and go right into sample data, actually on top of content. So now just move it over to content. Yeah, just drag it and lay it on top of the word content. You got it. You
Okay.
got it. All right. I'm telling you, you're getting good with that mouse. That's all right. So now when you go up to runtime, up in the menu, you see all the
In
way
the
in, actually all the way up in your Google Colab, go over to runtime on the right.
oh yeah,
Yeah,
runtime.
click there and run all. And
Okay.
let's see if it's able to find your file.
Okay.
All right, and let's see what we've got here. So why don't you, is there any way you can get rid of the penguins menu window and just show me
Window,
the,
I think I could do that. Let's see.
yeah, just click on the box there. There you go.
Okay.
And that should make it bigger. Excellent. So now if you could move the scroll arrow, yeah, so I can see all the way up to the top. All right, so it was able to load your libraries and load your
Mhm.
file. And then it got to a point where
Oh
right
yeah,
there.
this one. Yeah, I was having trouble with this one.
Okay, okay. So did you ever get to the box plot when we had class?
Uh,
It doesn't look like you got your box plot in there.
it should run. Wait, I want to try it again. Ah,
Okay, that's all right. That's okay. So here's what I'm going to do. I'm going to share my
okay.
screen and you want
Oh,
to
it
then,
did. It
okay,
did
that one
run.
ran, but the
So
sort
I don't
didn't.
know.
All
Okay.
right, try.
Oh,
There
this
you
one
go.
ran.
There you
Okay.
go.
This one was the one I was having problem the last time. This one, yeah.
Yes, yes, yes. So
Yeah, this one.
this
I
is
don't know what
actually
I was doing wrong.
right. So what I'm going to do is I will show you what the code should look like. So I'm going to go
Okay.
back and share my screen, but you're good to
Okay.
go there.
Okay,
Excellent,
no
excellent.
problem.
All
Thank
right.
you. I'm
You're
gonna stop sharing.
welcome.
Yeah.
No worries, no worries. Okay. So the example that you were having problems with, let me jump back. It was sort by month. This one right here, am I right? So it looked
Yes,
to me
yes.
like, okay, so you have a lowercase m for month, don't you?
Oh, yes, yes.
Yes, so there's the issue. So let's talk about that. So in the data set, capitalization matters. So since you have a
Okay.
lowercase m, it can't
Mm-hmm.
find it. That is why. So if you change that, everything else should be the same, I believe, if I remember. You should be able to run that with no problem.
Okay, I'm gonna do that now.
Yeah, let me know if it
Thank
runs.
you so
You're
much.
welcome. You're
Okay.
welcome. Yeah, so that's something. Python is a great programming language, but it's not forgiving. So if you don't remember the case of like the column name, it's going to get cranky and it's not going to know what month is, even though it should. And that's just because it's, case sensitive. So always check that first. That's usually what it is. Okay. Um, all right. So did everyone else get up to the box plot? So you should have, this is your very last item of code, as it were. Yes? Woohoo! All right, who remembers what is those dots that you see on the screen outside the whisker? Who remembers what those are? Outliers. I heard that word, outliers. So we have a lot of data points outside the whisker. Now the whisker in case here is it's past the 75th percentile. So all the outliers are outside of the whisker. So we have a lot of high amounts, pun intended, for our spending, right? Unusual amounts. Now, and we ended last week with talking about when you see this, you don't want to get too excited or too worked up, but you want to think about what could be driving those outliers. Why do we have a lot of unusual amounts? And are they reasonable given what we know about our spending? Okay. All right, so now what we want to do, we're continuing on, and again, I'm doing this because I want to make sure everyone feels comfortable before we go to Airbnb. Now, we are going to be continuing adding code cells in. So what I want you to do is just mouse over in the center here, kind of like I have here, and click on the code button to insert. Let's insert like 10 cells, just to give us some room to work with. All right. And again, the data pre-processing section, we haven't even gotten to yet, which is okay. So we're going to insert like 10 cells just to give us some space to work with here, kind of push everything down. All right. Now, we know there are outliers, okay? We also know that some outliers might be normal. Wouldn't it be great to see a table with our frequencies that show us what percentage for each category of spending we have? Let me show you how that's done. All right, we want to display the frequencies per category using percentages in a decimal form. So we're going to describe it in decimals first. And the way we do that is we use the print command. We want a very simple printout of the decimals. That's why we're using the print command. Print parentheses, the name of our data frame, the column that we are worried about, which is the category. We want to see what percentage each category represents, right? Category dot value counts, which means count the number of values that have been assigned to each category, right? So when we do our budget, we're basically assigning a category of spending, whether it's our mortgage or what have you, right? Our housing, maybe it's transportation, you know, our pets, food, and whatever, right? So value counts gives us basically the count of each value. Sounds very much like Excel, doesn't it? Right? But if we want to get percentages, but as decimals, we say normalize equals true. That means show it to me as a decimal format without the percent signs. Okay.
The one that we
And again, if you want to put the comments in there above, it's a hashtag to start a comment line in Python. And the reason I put these comments in is so that you understand what is my code doing. And that's way you have that as a note in your code and it helps you remember. Now, as you may have guessed, our housing category is the highest, and that's very common. If you have rent or mortgage, you're going to pay that every month and it's going to be expensive, right? Potentially. Okay, so unless you don't have a mortgage or something like that, but housing in this case is the highest category. It's 23%. Personal care is 19%. Loans is 16%. And I'm not rounding up, but you can kind of see the numbers there. Transportation is then, you know, the next one. And if you have, you know, expenses for, you know, car insurance or, you know, driving here or there, you're going to have, you know, transportation is going to be higher. So you can kind of see which ones are the highest, and then it kind of trickles off. Okay. Pets. Now, in this case, we pay more for our pets than we do for our food. But remember, with pets, you might be thinking, well, that might include, you know, going to the vet, getting vaccinations and things like that. So it's very common maybe for pets to be higher because of the vet bills, right? So again, if this were your budget, you would want to be looking to see, does this make sense or is something not right? Okay. Now, we can also investigate further and we can drill down into a particular category. Now, how do we do that? Well, right now, our data frame is everything, right? Our data frame has the data and how we brought it in. What I want to do is show you how to create a new data frame. Yes, go ahead, Maya. You have a question?
Yes, if you don't mind, can you please explain one more time this code?
Yes,
Print?
yes, absolutely, absolutely. So we're printing, and anytime you print, what it does is it creates a printout that looks a little bit different than a data frame. right? It actually just prints it, kind of like we did Hello World. It just gives like a message. In this case, it's actually a little table, but it's not a data frame. So it has an index. It looks like a table, but it's not a pure data frame. In other words, you would have to tell it, by the way, you're a data frame to be able to treat it as a data frame. So we're saying print out the contents of our DF, which is our data frame that we declared originally when we brought our data in. And if you forget what DF has in it, let me just show you. So DF has, let me just run that quick. Remember, it looks like this. This is what a data frame normally looks like, right? And you can see our table looks very different. So what we said is print the contents of the DF, the category only, right? And give me the value count. So what it's doing is it's going through the data, and each time the category is housing, it's going to give it a 1 and keep counting. I've got 1 for housing, 1 for housing, 1 for housing. It's going to do value counts for the category and add them up behind the scenes in memory. And then it's going to normalize equals true, meaning represent it as a decimal. All right. And that's what it's done here. Does that make sense?
Yes, thank you so much.
You're welcome. You're welcome. And again, we can see the difference between our data frame and the little table that we created here, right? Big, big difference. All right. So now what I want to do, and let me just make sure there's no other questions. Okay, it looks like we're good. And if I missed you, go ahead and put your hand up. That always helps me to see, right? So what we're going to do is we're going to create a new data frame. Now, I'm going to just replace this cell because we don't need that one. So we want to filter our rows to focus just on one category. And in this case, we're going to look at personal care because maybe we want to remember, well, what do we call personal care, right? So we're going to create a new data frame, and this is the name of our new data frame. DF underscore category underscore personal care. So we're saying this is the name of a new data frame. That's the name of it. And it's going to be equal to a subset of our old data frame, the other data frame. So this is like a filter in Excel, right? This is like a filter. So give me a new data frame, call it DF underscore category personal care. And what is going to be in that data frame? Well, we're going to filter the category to just personal care. Just personal care. Okay. So that's the first part of it. The next part, and I'm going to go ahead and run this and scroll up so you can see. The next part is to do a cross tabulation, kind of like a pivot table. Give me the category of personal care and break it out by each thing, each transaction that I assign the category of personal care. All right. And that's these above here. Dry cleaning, hair and nails, health club, holiday club, medical, organization dues or fees. Those I basically lumped all together as personal care. So as I was doing my bills and my budget, as soon as I got to my dry cleaning expenses, I assigned it a category of personal care and I put the dollar amount. Okay, we'll wait till everyone gets that typed and then I'm going to go through and explain that code again. This is an awesome way of filtering out data. And if you've done it in Excel, this is how you would do it in Python.
This is my account. This is my account.
Now you'll notice that there's a lot of square brackets, right? So in that first line of code, make sure that you have an even number of square brackets, open and closed. So notice here we've got 2 open, 1 closed, and then 1 closed. Also, don't forget the apostrophes, right? For the category and the personal care. Is anyone stuck with this code? It's a lot, right? You've got your parentheses, you've got your square brackets. But this is a very valuable technique.
Probably that's correct.
I have to go screenshot.
That's fine.
So basically what we're doing is we are assigning, remember, assignment always goes from right to left. So we're assigning the filter, which is a portion of the data frame. So in my data frame, in the category, right? Or the column, I should say, called category, right? And specifically any value that was personal care. So the value found in the category column in the large data frame, assign it to a new data frame called DF underscore category personal care. Okay, so it's say create a new data frame. Now you might be wondering, well, what does that new data frame look like? You might have guessed it. It's the data frame with all the personal care and only that. So we filtered out the others. You see that? We filtered out the others. So what this is answering, this cross tabulation, is how many times did we spend in the year for dry cleaning? How many times did we spend for hair and nails? And we can kind of see and make an inference that when we see a 12, it was like a once a month kind of thing, right? Because we got a lot of 12s here. So it looks like every month for some of these items, we have, spending. The question then becomes, well, what kind of spending? Well, that is over here on the left. The amount that we spent is here. And the number of times that we spent that amount is on the right. Does that make sense? So total occurrence is how many times, and the amount is what did we pay? And then within each one, so for example, for dry cleaning, $25, right? Notice that dry cleaning, the intersection between dry cleaning and the amount, we have a 12. So that means each month or 12 times we spent $25 on dry cleaning. So you're looking for the intersection between the column, right? So like hair and nails, and we have a 12 right here. So, oh, we spent $45.50. How many times? Well, 12 times. Okay. Let's say we look at medical. We come down to where the 12 is and it intersects with $50. So that's how much we paid. So it looks like we paid something per month, $50 per month, 12 times. Is that starting to make sense to everyone? So this is kind of like a pivot table with where we have sum of, or in this case, we're counting the number of times and not summing. Over here, we know the dollar amount and it was the same each time. All right, in this particular example. Now, the crosstab code, PD stands for PANDAS, right? Remember, we brought that library in. Well, PANDAS has something called a crosstab, and a crosstab is a cross tabulation. It's kind of like a pivot table. So we created a cross tabulation of the personal care, the new data frame we created, and we're using the amount and the description, and we're creating margins, meaning on the left and the right. And in the margins, the name is going to be total occurrence. Okay, so this helps us understand what we spent and on what. Holiday Club, we have 12 times where we spent $100. So maybe we're saving up for a cruise or something, right? But we know that 12 times we spent or paid $100. And usually a holiday club is like a savings. So that makes sense. Maybe every month you have, amounts coming out of your check or what have you, your bank account for a holiday club. Questions on that? Is that kind of cool? Kind of scary? Now you might be wondering
Quick question.
Yes.
The true margin has to be true always when we're creating the
If you want, yes, if you want to see this right here, in other words, a tabulation on the side, yes, it needs to be true. If I turn it to false, right? Whoops, helps if I could type there. Then I'm not going to see that totals on the side, right? So if I want to see the total occurrence, I need to flag it to true. And this way I get to see a total. So when I see that total occurrence, it looks like, hey, these expenses were on a monthly basis because they're 12, 12, 12, 12. Make sense? So
yes,
again, yeah, you're welcome. You're welcome. A cross tabulation has the ability to show totals on the bottom and on the right. And so that's what's kind of cool about it. It gives you the details, right? And in this case, we asked for, the count of things, but then what it does is it gives you those totals, which is kind of nice. Now, again, this data frame that I created here has just, notice 72 rows and 5 columns. It has just the personal care transactions and none of the others. So that's how you create a new data frame, which is a filter of all the data. And what we did is we basically took just the personal care category. So roughly 20% of our data, we said, let's put it in its own data frame. Now, why would you do that? A lot of you might be wondering, well, why would I do that? If you want to create charts that represent just that particular category, or you want to focus or narrow down on just one aspect of your data, that's the best way to do it. And when you name your data frame, you want to make sure it makes sense. So here I know I took out the personal care category from my larger data frame. It makes logical sense. So don't start naming your data frames DF1 and DF2 because you'll never remember what's what. All right. Oh, or you might remember, but good luck remembering it tomorrow when you go back to your project. You won't remember. All right. So everyone understand? Any questions about that? All right, let's focus on another one. Let's do frequencies for just one column. Let me close that and get rid of that. We're going to display frequencies for description. Now, you might be wondering, well, we ran frequencies up here, but that was for all the data. Now we want to see within the description category, what percentage is allocated to what? Now, in order for you to do this, you have to know what's in the description column. So I'm going to run this and show you. The description is basically the specific spending areas within a category. I'm going to scroll up here. There we go. Whoop, it's too far. There we go. Again, we did normalize equals true to get those decimals, okay? So this is how we take the description and we break it down. And this also assumes that the description is going to be the same. Anytime we have a medical expense, we always call it medical. If you spell it two different ways, it's going to create a separate description. So that's why, you want to make sure your data is clean. In this case, I gave you a clean data set. So we don't need to worry about maybe something being spelled two different ways. But you can understand that what it's doing is it's looking for matches. And within each group, It's going to count how many of them there are and then tell you what percentage of that is represented in the data. And as you probably guessed it, remember medical was really high. Well, sure enough, medical is about 7% of all of the transactions within the description. So that makes perfect sense. And then the rest are kind of balanced out over throughout the data set. So we're starting to see a pattern here, right? So again, to recap, we created a separate data frame. We had frequencies for the category. Now we have frequencies for the description. Okay. Now I'm going to show you another trick. Everyone got that? I can scroll past this. All right, awesome. So now what we can do, now that we know medical is basically the highest category, right? I'm going to show you how to filter all the rows out to focus just on the medical description. See how we're drilling down and we're creating a new data frame to do that. So we're focusing, instead of category, we're focusing on, remember, medical was under the personal care. Now we're looking at medical only in the description, and we're creating a new data frame. We're also cross-tabulating very much like before. And I'll just show you what it looks like. Now you can copy and paste your code from the prior example if you want to. That's not cheating, that's just being smart. Time saver, it's up to you. So where we did that other cross tab, you would just want to make sure that you tweak the code so that it matches our goals. And then I'm going to explain what the result is, what it means. Because if you don't understand the result, that's going to be an issue. It's one thing to get a result with no errors. We love that. But if we don't understand what it means, that's a bigger issue. So we'll talk about that. So in this case, we had medical expenses for both the personal care category and the pets category. So we can infer that, the personal care is maybe our co-pays that we have to pay, for medicine or what have you. And of course, our pets is for vet bills and things of that nature. So we see here that the dollar amounts are different, which makes sense, depending on, what exactly you know your spending is about. But we can see the dollar amounts on the side here. Everyone okay with that code? Does everyone understand the code? So how many times did we have personal care expenditures? Anybody?
12.
12. Awesome. And what was the dollar amount that we paid?
50.
50. Awesome. How about pets?
12.
And how much did we spend?
125.
Perfect. Awesome. All right. So this is a great way to see sort of two areas, medical, right? That would be part of our medical expenses, and see how they're broken out. Okay. Now, another thing I'm going to show you is how to filter out based on the dollar amount or the numeric amount that's associated with these things. So let's look at another example. This is, again, is a filter. I'm going to create a new data frame that's called DF filtered, but it's focused just on the amount. And I want to see cases where we spent nothing. in a given category. Okay. So it looks like we didn't go to a lot of sporting events that year, right?
Oh,
Now, again, this is not a data frame. It is basically a representation of a potential data frame. It's not until we actually call the data frame, like I did down below, where we actually see a true data frame. All right. That transaction ID, by the way, was created as a unique way of referring to the transaction. So as folks probably know, like when you go to the store, what have you, there's always a way to keep track of the line item, and it might be a short number or very long number. In this case, it's a very long number, which is okay, as long as it's unique, which we know they're unique. But I left that in there so that, we could talk about, well, why is it this way? Every system, whether it's an accounting system or otherwise, has a way of uniquely identifying a record. So as long as it's unique, we don't worry about it. We're not going to use the transaction ID per se, but it's there. And as long as we understand what it is. So here we've created another data frame. We filtered to just the amount in the case where it's 0. And this is what the data frame looks like when we print it out. And then this is what it looks like when we run or view the data frame, which is very familiar to us. We've done this before. And we can basically see that each month, notice we look at, each month, we didn't have any expenditures for the entertainment category, specifically sporting events. So we've been good. We haven't gone to any sporting events. So if, let's say, our spending was, larger than we thought in general, we can rule out sporting events as being the reason why, because it's 0. Makes sense to everyone?
could you show the code again? Because I didn't get the
Absolutely.
right. Okay, thank you.
Mm-hmm. So does everyone understand how a new data frame is created and how a filter of the prior data frame is then assigned to the new data frame name variable? And what's cool is you could have a bunch of different data frames, very much like in Excel, having different sheet tabs within a workbook, right? And you might have data on each of those sheet tabs. And maybe you're running that data, making charts, doing formulas and what have you. This is how you do that same idea with Python. But what you're doing is you're basically creating data frames, and you can call those data frames. You can show them on the screen. You could then make charts based on them and what have you. So it's very convenient because you get to narrow down your focus on just what you're interested in for that purpose of the analysis. Yes, Maya.
Okay, I'm looking at my Google Sheets, and you print DF filtered, and then we have only DF filtered. So I'm kind of confused with that.
Okay, so here we use the print command to show the results of the filter that we did here, right? And so when you do a print, you could print out anything to the screen. And that's what we've done here. We've printed it out to the screen. But notice how it wraps around. It's kind of hard to read, right? What we did is we printed it just to confirm that, yes, the filter is working the way we intended. So it's kind of like having a window at the bottom of your computer showing you the output results, just to show that, Yeah, it did filter correctly. I have just the amount is equal to 0, right? Now you don't
Now,
have, yeah, you don't
now
have to have that. Yeah. Um, and when we look at it, it's not very pretty to look at because it kind of wraps around and what have you. So that's why we can then call that data frame that we created and see it normally so that we can read it without it wrapping and looking the way it is. Right? So, but I'm so glad you asked that because that creates a lot of confusion. Anytime you want to print something to the screen, it's usually done for confirmation purposes. In other words, it's almost like debugging your code to make sure it worked correctly. Keep in mind that if I comment this out, let me just show you a trick here. Let me get my cursor where it belongs. If I run this and I create my filter, I don't know if it worked. Now I could be really bold and just call it and say, I think it's going to work. I'm just going to run this and yes, right? But let's say you're not sure and you just want to print it out to make sure. That's where print comes in very handy. It just gives you a confirmation. Yeah, it works. And now I can move on. So again, not required. Not required. Does that help?
yes, thank you.
You're welcome. You're welcome. All right. So the next thing I'm going to show you is how to create a chart for our amounts. Now, a histogram is based on what type of data? Do you guys remember? It is, it's got to be numeric, right? And amount is numeric. Could we take a categorical variable and put it in a histogram? No, because
No.
it's not numeric, right? So what we're about to do is create a histogram, and we're going to use the amount column to be the basis of our histogram. And amount is the only numeric value that we could do a histogram for. So it's going to create a histogram for amount because it's going to say that's the only numeric I can do, right? Now, when you do a histogram, it's going to look at all of the values you have, all the numeric values, and it's going to try to put it in bins. It's going to make ranges, right? We don't want it to do it without us telling what we want. So we're going to say to it, we've got 10 bins that we want. And I'm going to show you the difference between 10 bins and 5 bins so you understand. When you create a bin, it's like a grouping of numbers. So think of it this way. Maybe I want 5 groups. I know that the amounts that I have maybe range. We know there's a lot of outliers, right? It ranges from 0 all the way up to 1700. We know that from looking at our data. So I want to chunk it up so that in my chart, I kind of cluster them in different buckets or bins. That's what a histogram does. So what we are going to do is create a histogram for, whoops, and I took my little hoogie out there. We want to create a histogram, and I did it again. My goodness gracious. Come on, cursor, work with me. Okay, a histogram for the amount variable. Okay, and what that's going to do, and I'm just going to scroll up here and then I'll scroll down so you can see everything. We're going to create a histogram. So we create a object called hist. We assign to it the histogram function of our data frame, and that's the original data frame. We want 10 bins, and we want it to be a 10 by 10 on the screen. So that's the size. The fig size is the size of the figure. So when I put my chart on the screen, how big do I want it? And I'm doing a 10 by 10 just so that it's easy for you to see. You know, in Excel, you can also determine how big your chart is. Well, that's how you do that in Python. All right, so again, it's hist equals, and it's going to be the histogram of the data frame with 10 bins, a figure size of 10, 10, meaning 10 by 10. Now, by doing it this way, you might be saying, well, you didn't refer to the amount. It knows, the system knows that the only column it can create a histogram for is the numeric one. And so I don't have to tell it the amount. I put it in the comments so you folks would know, but a histogram is basically used for numeric values only. And my data only has a number in the amount column. We do have numbers in the date, but those are actually text because they're not formatted as dates, and even a date is not a calculatable number. All right, and I hope that makes sense to everyone. So can I scroll down? Everyone good? Yeah,
Yeah.
there's our 10
No,
bins.
not yet, Professor. I
Okay,
don't know.
okay,
Yeah.
okay,
I'm
no worries.
sorry. I'm just
No,
trying
no,
to
that's okay. That's okay. That's all right. That's okay. Now, while we're waiting, I just want to mention to everyone that when you select a chart, there's a reason you select a particular chart. Remember, a chart is considered a data visualization, and every type of analysis lends itself to certain types of charts or styles of charts. The goal is to communicate the results to whoever it is you're communicating with, right? Okay. And so you don't want to be arbitrary in how you select charts. You might like a chart because it's cooler looking or what have you, but maybe it doesn't effectively communicate the data. So you want to just remember that, right? I'm going to scroll down and I'm going to zoom out just a little bit so you can see we have 10 bins down here. Everyone see that? If you look, we've got our data grouped into 10 buckets or bins. You can see the logical break off based on the bars. And even the little mini me down there, the one that's really, really tiny, and then we have another one that's super tiny, they're there, right? They are there. So how does it know how to break it up? Well, if we say 10 bins, it looks at the range. It looks at 0 to 1750. And it says, break it up by 10. And if the value or the amount belongs in bucket 1, we're going to put it in there, right? So bucket 1, if you look at it here, bucket 1 only goes so far, and then the next bucket kicks in. You see that? And then the next bucket and the next bucket. Okay. Now remember, we had outliers. Sure enough, we have outliers, but there's not a lot of them. There's more of the other data, and that data is what made the whiskers. Remember the whiskers in the center? There was that box in the center of our box plot. That's these guys right here, the big tall guys, all the way on up to 1000, right? And these guys are the outliers. So this is almost like looking at your box plot differently. Does that make sense to everyone?
I have a question.
Yes.
When you said that we were doing, big size 10 by 10.
Mhm.
And then I look at the graph, it's really at the squares that I'm counting is not 10 and 10.
Yeah, that's not squares. That's the size of the graph. So that's
Right, it's the graph.
pixels.
So am I supposed to have 10 across or no?
No, no.
Oh, okay, so what's determining how many squares I have
The
right now?
squares is based on the data. So the range of data. And so what it did is it created your range is between 0 and 1750. And it's not going to show a grid for data that's not there. So it looks at available data and it creates your histogram and the grid system based on that. Does that make sense? So it looks
Yes.
at the largest possible value and it looks at the smallest possible value and it goes from there. But it's also a function of your bins, right? So if I say 10 bins and the max is 1750, that's what's driving the number of squares. Does that make sense?
Yeah.
Yeah. So
Yeah.
so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And what it did is there's only 10 bins, but they fall in between. So these
Mm,
squares have nothing to do with anything that we called for up here, if that makes sense.
oh, okay, got it.
Right.
Got it. Mhm.
Now, if I change the bin size, let's try something. Let's take it from 10 bins down to 5 bins. So just replace your 10 with a 5 and rerun it and see what happens. Your range is still the same because the data hasn't changed, right? But now you've got more values that fit in a given bucket because
Right.
we changed the realm of possibilities. We only have 5 buckets, so we have to put it where it belongs. So the first bucket ends roughly around, well, you look at 250 and then 500, that's a 500, basically 500 difference. So it is basically up in, I'm gonna say maybe 275-ish or so. Yeah, right? So anything that's between 0 and 275 goes in bucket 1, and then it keeps going and keeps going. So the more buckets you have, the more spread out it's going to be. Remember, it's not changing your data. The less buckets you have, the more that you're going to have in each bucket, right? And it's going to put the data points in the given bucket. If we change it to 7, all right, it's going to be more spread out, but the data doesn't change. It's still between 0 and 1750.
So what determines the amount of bins that I decide to have in a given graph? So in this case, the histogram.
Well, what this is, the bins is the number of buckets that we have that the histogram will represent. So typically based on our goals, we decide what the bins will be. You don't want a bin of 1 because then everything's going to be in one big bucket, right? But what you do is you say, I'm going to organize my thought process to try and see which bin is the highest. So we went with 10. And the reason we went with 10 is that was representative of what we knew about the data. And we can kind of see here that we've got a lot in that first bin, right? So a lot of our transactions are smaller size transactions, right? And as we go along, as we remember, our spending is on the x-axis.
Yeah.
Okay. And the amount that we spent over time is on this. So how many times and how many of the transactions fit in there? All right. Now, our 1750 doesn't happen a lot. Okay. But you can kind of see that the majority of our spending is on the smaller side. That makes sense. Okay. Now, of course, you could change the size of your figure. So let's see what that looks like. So let's change the 10, and instead of 10 comma 10, let's make it 5 comma 5, just so you can see visually how it changes the size. A lot smaller, right? Now that's still readable. It's still good, but it's smaller, right? It's actually half the size. And I actually changed my zoom, so let me reset. So it's it's still legible. I can still see, but it is definitely smaller. So when you're displaying the size, or you're displaying the graph rather, if it's too small, you can make it bigger. Now this happens to be square. So that's why we're changing the numbers to be the same. In some cases, your graph might be wider than taller. And so you have to know your graph. You want to be really careful that you don't distort it so that when someone looks at it, they get the wrong idea about your data. So we're going to take it back to 10 comma 10, just because we can. So this is how you would change the size of your graph in Python. Pretty cool, right?
Yeah.
All right. So you survived that part of it. How cool is that? Yay. All right. So what we're going to do is we're now going to jump into the data processing. So if you have extra rows like I have here, we can go ahead and delete them. And the way that you delete them is you just click inside the row and click on the garbage can. We're just going to delete them just to make it look nice. And we're going to insert a code cell under data pre-processing. So now that we've gotten a look at our data, mind you, we've done a basic exploration of our data. We have a good idea as to the patterns that the data is showing. We do know that there's some columns we don't need. Remember that transaction ID column? We're never going to remember those values. It's too big, right? and we really don't have a use for it. So we may want to get it out of our data frame so that we can focus on just what we want to look at. That's one thing we need to do. The other thing that we have here is we do have the amount, but maybe we want to convert it to a float. Right now, our amount is only 1 decimal, and we know that dollars and cents, is going to have 2 decimal places. That's something else that we want to do. We also want to tell it that, I really need dollars and cents. Now, I don't believe we have any, actually, we do have some values where it's like 75 cents. And that could make or break. So I'm going to show you how to create that. That's another data preprocessing task we have to do. The other thing we want to do is get rid of any rows where there was no transactions. So if we didn't spend, we don't want to worry about it, because we're worried about what we spent and where, right? So I'm going to show you. And data preprocessing is designed to narrow down our data set to something that we can then visualize and present and get at the questions that we ask in the very beginning. So I'm just going to quickly scroll up. You don't have to scroll up, but if you remember last week, we started out by saying our goal was to understand what columns are available, what data values are present. Well, we've done that. We've kind of gone through the data. The next is to detect overall spending trends and patterns. We've gotten some patterns we've noticed, but we still don't have a really good picture as to what's driving the outliers. We know that it's probably something like, maybe mortgage or something like that, but it doesn't seem, something seems off, and we still need to get into that. The other thing is the unusual spending. Did it occur in, a given month? Did it occur in a given category? We don't know. All we know is there is some higher spending going on because we have those outliers. So the questions that we had asked last time was how much of the budget is allocated to each category. We determined that. The next question was, is there any category that stands out as high or low in spending? We determined that. And what we didn't answer is, does spending change throughout the year? So we have one more question that we need to get the answer to, the insight. And so now we're going to go into data preprocessing, clean up our data a little, and that's what preprocessing is. And then we'll go to the next part of the analysis. All right, so here we go. This is why you don't just jump into the analysis. You kind of have to get a feel for your data. So the first thing we're going to do is get rid of a column that we have talked about that we don't need, and that's the transaction ID column. So this is the code for dropping a column, one or more columns. In this case, there's only one. So it's df, or data frame, dot drop. Now keep in mind, we're dropping it from the original data frame. The column called transaction ID, remember case matters. Access equals 1 means drop it from the first axis, meaning the column where that is, take all the data on that axis and drop it. And in place equals true means within the data frame. So basically get rid of it. In place, it no longer exists until I re-import my data. And I'm also going to insert some code cells in here so that we can do our data cleaning. Now, just like in database, you never want to drop your tables really quickly. You want to be very sure. If you do df.drop and you don't specify what to drop, it will delete your entire data frame. That could be very bad. We want to delete just the transaction ID column. So you want to verify that you spelled it correctly before you execute it. Otherwise, you have to re-import your data, basically end the session, re-import your data. It gets messy. So always before you execute this, make sure that everything is spelled correctly and you're referring to the column that you indeed want to delete. All right, and I'm going to go ahead and execute mine. You won't get a confirmation that it happened other than the green check mark. Now, if you're wondering if it happened, we could do different things. We could do print DF, just a quick print DF to see, and it's no longer there. So we accomplished our goal and we didn't annihilate the entire data frame. Woohoo! It's always good to check. It could be a Monday morning and you're not thinking clearly and you go and you execute code and realize that, oh my gosh, what did I do, right? Now, what's nice is your original data is not destroyed because we have that in a spreadsheet, right? So that's a good thing. Everyone good with that? So that's how you drop unnecessary columns, one or more columns. In this case, we just have the one. If we had more than one, we would actually separate each one with a comma. But in this case, we only have one. Now, if you go to execute that command more than once, it'll yell at you because it's already dropped the transaction ID. So if I go to run this again, it's going to throw a nasty error, and that's because it doesn't exist anymore. So if you're curious, right, and you go to run it again, it's going to say it's not found in the axis, and that's because you said bye-bye and you got rid of it. So that nasty error just means that,
Okay.
right, once it's gone, it's gone.
Yeah, I did it more than once.
Yeah, if you do it more, if you execute it more than once, you're going to get an error, and that's because you can't delete that which doesn't exist. All right. Now, another thing that we want to do, everyone's good with the deleting of their transaction ID. Now, again, you can verify that it did in fact delete. You can just run your DF and say, oh, it's no longer there. It looks so much cleaner without it, right? So you can just quickly run DF and see, it's not a large data set, but this way it's gone. And that's why when I ran it twice, I got yelled at because it doesn't exist anymore.
So
right?
instead of print DF, we just put DF? Or just
That's
run it?
correct. Right.
Oh, okay.
I'm doing it this way. It's easier for you to see. Yeah. You can do print DF either way, but for you seeing on the screen, it might be easier to see it this way. All right. So everyone was able to delete the transaction ID column. Yeah. All right. The other thing we want to do is you'll notice that the amount column, or excuse me, the month column does not represent a month. Everyone okay? Anyone stuck? Okay. So the month column is not a month, it's a date, right? So we want to actually change the name of our month column to make it the word date, because that column does not represent a month, it represents a date. So to rename a column in your data frame, this is the syntax for that. It's df.rename, very logical. Rename is a function, just like drop is a function. And then in parentheses, anytime you have a function, just like print in parentheses, this is a function, rename. What do we want to rename? Our columns. And this is using key pairs. So the month column will get changed to date. So we're basically remapping it so that month is replaced by the word date. And we're doing it in place. We're actually doing it to impact the data frame in place so that the data frame, that column, will have a new name to it. Now, it's not changing our spreadsheet. We know that. But in this data frame for this session, it's changing it. And I'll just prove that it happened just to show you. And again, it's more logical. If you look at your data and it doesn't, really make sense to call that month, make it date. That makes more sense. Now be super careful. We've got parentheses, right? Remember, all functions, it's the name of the function and then parentheses open and close after. And then inside of the parentheses is going to be the parameters or arguments that you're providing to the function so it knows what to do. So inside of that, you will often see either curly braces or you will see brackets, what have you. Depending on what you're doing will determine whether or not you use curly braces, brackets, or what have you. So here, this particular keyword mapping is done with the curly brackets. So we're basically mapping month to date. So that's why we have curly brackets around it. All the tricks of the trade you're learning tonight, all the tricks. This will be a very good reference workbook for you.
But it didn't change the date, did it? Oh, yeah, well, mine didn't.
So your month column should no longer be there. You should have the word date
Oh, I
as
have to.
the name of the column.
Yeah.
All right. And again, it makes sense when you're looking at your data, it makes sense. So you want to, part of data pre-processing is making sure that your data frame and everything in it makes sense. So sometimes you're renaming columns, sometimes you're changing, the formats and such. So that's why we did that. Now what we're going to do, we talked about the amount column not being the proper data type. We want it to be a float. If we came back up here, we can see that there's only one character, one digit rather, after the decimal. And we don't want that. We want to represent all of the cent values. So the way that we're going to do that is convert it to a float. A float data type takes an integer and converts it to a float, which is a decimal. And once it is a decimal for sure, which we want to make sure it's a float, we can then tell it how many places we want to see for that decimal. So this is the code to convert a column to a specific type, data type. So as type is basically in parentheses, you say what type, as type float. We want to make sure that that amount column is a float. So this is data cleaning that we're doing, and pre-processing is that data cleaning. These are some very classic examples. And these are things that you want to think about in your toolbox, right? Of things that you can do. Now, if you're not sure that amount has the proper data type, you can do df.info. Remember that from way back, yes, last class? Well, sure enough, after I run that command, it is a float 64, and that's what we want. So we told it you're a float, and now it knows it's a float. And if you remember me saying that in order to treat your data a specific way or run specific processes or do conversions or formatting or what have you, the data has to be in a certain data type to allow that. Okay. So was everyone able to convert? Yay. Now I'm going to show you why we're going to change the amount column. So let me put this code up here for you. So Pandas allows us to change how the values are displayed, and it can actually address a specific data type's format. Floats have different formats, decimal places, right? And you've done this probably in Excel. Well, this is how you tell it to format it to 2 decimal places in Python. All right. So basically, we're telling it to display any of the data that is a float in a specific way. So the first part of the value before the before the decimal on the left side of the decimal, it's going to leave alone. But on the right side of the decimal, we're going to have two places, and that's what the 2F means. Lots of stuff to learn, huh? Lots of stuff to learn. We've probably seen in Excel where you can change the number of decimals, right? You can go to a very high precision, have multiple places to the right of the decimal point. When it comes down to money, we usually want to see just the dollars and cents. And the danger of not seeing the cents, if let's say it's 50 cents, now we actually see that this one is 45.50. We would have not maybe guessed that if we didn't have that full two places. We would have seen the 5, but what it could be 55, right? We didn't know. Now we know that it's actually 50 cents. Does that make sense to everyone? So by having two decimal places, we know that it is truly $45.50. And you never want to guess, right? You want to make sure that you format your data so that it tells an accurate story. Now, this is another one where you're using curly braces. And this is a mapping function as well. Okay. So what it's doing is it's taking anything that is prior to the decimal point, and it's making that basically good. It's keeping it. Notice there's no specification here in front of the colon. That means leave as is. I know it's weird, but leave as is. There's nothing on the left side of the colon. Like up here, we had month. So it says, oh, okay, month, make month date. Here it's saying you don't need to do anything for the first part because it's good, right? And that's, the left side of the decimal. But on the right side of the decimal, which is the other piece, make it two places. And that's what that 2F is. Yeah. All right. So when you do a mapping like that, there's times where you have to tell it to ignore, and it just says, oh, there's nothing to do there, but on the other side, I need to do this. Okay. Now, keep in mind, this command, if you had other columns that were floats, it would convert all of them. If you only wanted to convert one, you would specify. But for now, we're going to keep it simple. We have one amount column, so it's just going to do the one that it has. Okay. All right, so that's another data cleaning that we can do. Another one that we wanted to do, because we know that in our data set, we have cases where the rows for amount are 0. And that's kind of clogging up the data set. Remember, our whole goal is about what we spent. And so the amount is what we spent. We want to get rid of any situation where we didn't spend anything because we don't need that data in there. And the way that you do that, again, very carefully, is do a drop based on a filter. So anywhere in the data frame where the data frame column amount is 0, all right, using the index of that particular row, delete that row. Okay. And before you execute that, you want to make sure that you have all the code done correctly. All right. And Maya, you're good. I see your screenshot there. Did you have any questions or problems? Your format did not give you, I see you have only 1 0, huh?
Yeah, yes, that's the question.
Okay, let's see here. Let's see. So what that probably means, well, that's very interesting. And you're sure you executed what was above? Try executing it again, where you changed it to 2. Maybe you thought you executed it. Do you have a green check mark?
Yes, that's what happened. I didn't execute it.
Aha. So that's a logically good, bad. A logically correct bad. That's okay.
Thank you.
You're welcome. So here's the thing. If you don't execute your code, right? Or if you get a result you didn't expect, always check to see why would that be. We definitely don't want anything mysteriously happening by accident. And I do that all the time where I forget to execute the cell that was directly above. And I'm like, oh, I don't have a green check mark. Maybe I should get that before I move on. So if that happens to you, again, don't doubt yourself. Look logically at the screen and say, what could be driving that? Right. And then once you determine what caused it, then you can fix it. Right. So it's not always something you did wrong. It could be something very logical. All right. Now, before you execute that code that we just did, which is to delete the zeros, any transactions that were zeros, make sure the code is correct. So it's df.drop parentheses, df square bracket. Remember, square brackets are different. They look very similar. df square bracket again, apostrophe amount, apostrophe square bracket, equals 0 square bracket dot index. In other words, go to the index of any row that has an amount of 0 and drop it in place. Get rid of it. Okay. Yeah. So now if we run our data frame again, we should not see any zeros. And in looking at this, we have no zeros. And of course, before you do drop functions, always be careful, right? Make sure the code is right and so on. If you're really paranoid, you could make a backup of, well, you have the data set, but you want to just make sure that before you execute it, that the right column is specified and such, because you'd have to go back and repair things, and that takes time and what have you, right? All right, we've got 2 more things to do. So when we did our df.info, right? When we did that, what was our date column? Does anyone remember?
Of the months,
Yes. Does anyone remember?
it was the month, no? The day was the month.
Well, a month is not a data type. Ugh, I can't talk. So when we ran it before, our date is an object, right?
Okay.
Yeah, so data type. So now the problem with an object is we can't treat it like a date. We can't treat it like, we can't say, give me the month when that transaction occurred, or give me the day or the year. An object is just a thing. It's like it's an object. It's kind of how Python brings in a lot of columns when it doesn't know what specifically you're trying to do. All right, so Renita has a question. Remind me what in place equals true means. So in place equals true is basically within the data frame, in place, delete. So if you think about it, you have a bunch of rows that are 0. In place means get rid of them, and basically your new data frame is minus those. So that's what in place equals true means. So basically you have a new data frame. Your df data frame, or the object df, is forever changed. Forever changed. All right, it's a new creature. So I hope that answers you're welcome. You're welcome. So now going back to our data type. So if we know that we want to determine what month these transactions happened, we need to be able to manipulate our date so that our date knows what it is. And what do we know about dates? Dates have months, they have years, they have days. And so in order to manipulate the date, we have to have a date data type so that it understands what the date basically is. So I'm going to show you how to do that. We are going to convert the date to 2 different things. So The first thing we're going to do is take, and this is actually our date column. It's no longer our month column. We're going to change our date column to date time data type, meaning it's got a date and time associated with it. It's basically a full date. All right. The other thing we're going to do is specify what we want to see with respect to our date time string format wise. We want to see the month and the year. Okay. So we're actually rewriting the data so that it fits the format that we want. And I'll show you what that looks like in a second. I want you to get that down first. Whoops. Go away. There we go. Let me scroll up so you can see. So in my data frame, the column called date, we want to assign to it the date time data type. Once we do that, then we want to get more specific and say, specifically, given the date time data type, give me the string value. All right. Reformat it so that it's month and year. (01-2020). So that dash is literal. Anything inside of those apostrophes with the hyphen, notice that hyphen is literal. So lowercase m means 2-digit month. Uppercase Y means 4-digit year. Good Lord, right? How am I going to remember that? Well, it's one of those things. It takes time. So again, that's another classic data cleaning exercise where you're taking the date and making it real. So it's a real date. And sure enough, when I run this, let me run this again, I don't see that date was converted to a date time. And there's a reason for that. We did 2 conversions. We converted it and then converted it to something else, a string, which is an object. That's okay. We had to convert it to a date time to be able to tell it that month and year are a thing. An object doesn't know that. So we converted it and then we converted it again. And we converted it so that we can see the date in a very specific format, 01-2020, 02- and that's for visual. We've already did the conversion. So for visual purposes, when we start doing charts and things of that nature, we want it to show a specific way. And that might seem really weird to you, but that's exactly what we did. We said, you're a date. No, you're not. Or you're a date. Now that you're a date, we're going to tell you how to format yourself and make you a string, because we can. We have all the power. So if you're wondering that when you go to look at the data type, it's because of this second line here. We actually converted it back to a string. So it's basically formatted as a string. And of course, when we look at our data frame, we see that it is in the format that we ask it to be. Pretty cool. Any questions on that?
Mine's not working.
Professor,
Yes.
mine is not working. They convert the column to date data type.
Okay. So why don't you share your screen? Let's see what's going on.
Okay.
It might be a comma or something along those lines, but let's just take a peek.
I don't know. Can you say?
I can see, yes. All right. So,
I keep checking it like 1 million times.
okay, that's all right. So basically the code right above where the red arrow is, right? That's not
Yeah.
working. And when
Yes,
you,
that's the one.
that's correct. So when you go to run that, what happens?
So when I run it, this
Okay,
is
it
what
gives
it's
you an
saying.
error. Yep. So now scroll down to the very bottom, past all that stuff, and it says series object has no attribute df. This is bad news. All right. So what it's saying is you created a series out of your data frame. So the first thing I'm going to ask you is scroll up to and run df.info, run 78, the one above. And
Okay.
let's see. Yeah, let's see here. Okay, so your data frame is still there. And it
Mm-hmm.
actually ran the first line. How do I know that? Because your date time 64. So line 1 of that code ran. The second one
Yeah.
did not. Okay.
Yes.
So now let's scroll down and let's see. So let's make sure it is correct. So you've got df date with apostrophes, and you do have, I'm just looking here, there are apostrophes. There's nothing wrong with them. df, so you referred to df, that should be dt in front of str. Yeah, dt. So it's date time. You put an f.
Oh.
So it's
Oh. So
dt.str. You got it. That
okay.
is why. You got it.
Okay.
Now it will work. See? I'm
Okay.
glad that happened to you. You want to know why? Because
Yeah.
we were able to determine that one line ran and the other one didn't. Now for info, you have a 0 instead of an O. And that's why it's not running.
Okay.
Yeah.
Okay, I'm good now.
Yay.
Thank you. I'm good.
Awesome. Awesome. You're welcome. You're welcome. I'm glad that happened because that gave us a great way of looking at, well, what did run? Like, remember, if you've got 2 commands in one cell, you don't really know which one ran, but you did definitely know that there was a problem. And what it
Yes.
was doing is saying, well, you're referring to your data frame as a series, but it's not. It's actually a real data frame. So that's where it got confused.
Okay.
And then
Thank you.
No problem. No problem.
Oh, yes, yeah.
Okay, let's see. Maya, you okay? Let's see what Maya has. Let's see.
Okay, look at me.
Okay. Do.
I guess after a little while.
Maya, do you want to share your screen? Your code is still problem?
No, she's not.
I can because I'm using my phone.
Okay. Okay. All right. So let's take a look here. So let me ask you this question. Were you able to run this command above? If you run df, what do you see? Let's do that first. So if you run like df, like I have on the screen here.
I can let me go back. It's a little tricky for me. I can see
Yeah, no
what you
problem.
have.
I can see, I do see what your issue is. You have a lowercase y instead of an uppercase y. So this should be uppercase. This one here, that's one problem. Yeah, that's one
Okay.
problem. Yeah. Do you want to try fixing that and see?
Yes, of course.
Let's see if that helps.
So that and didn't work again.
Okay,
yeah.
it didn't work. Okay, so that was one issue. And I'm just looking at your code here, and it's let me zoom in so I can see a little bit better here. Because I'm old, I can't see things sometimes. All right, you've got date, apostrophe, 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 dot dt, strf time. Okay. This is interesting. So I can't see the bottom of your code. Can you run it again and tell me what it says at the bottom of the error?
On the bottom, all the way to the bottom, it says parse error, unknown string format, 01 dash.
No, at the bottom of
Other-
that though. At the very end of the error. What does it say?
Oh, the one again, so it should be,
Search Stack Overflow.
Yeah,
Let
but
me take a picture.
yeah, if you would, it'd make it easier for me to see.
no, it looks good now. Now, let me see. Well, give me an error. Yes, it's good. Let's see, okay,
Because so far I'm not seeing anything, but I would like to see what it says at the end of the error so I can hone in on it. All right, there's your second one. Okay. Unknown string format. Okay, somewhere it sees a V. So the question becomes, all right, do me a favor. Run your DF again and tell me what your data frame shows with respect to the date.
So can you hear me?
Uh-huh.
So on the end, because I have something after that, I have one DF after that. Do you want me to rerun that one? Or just
Yeah.
code?
Mm-hmm. But just the data frame, not the info.
Yes, data frame. Yes, okay. So I have it.
And it looks normal. What does your date look like?
No, it says 01 dash percentile V.
Ooh, okay. So it blew up your date. So because it blew up your date, it can't do the conversion because the date is not what it should be anymore. So in this case, what you'd have to do is re-import your data and start over.
From all
Yeah.
the time?
Pardon?
From all the way from the beginning?
Yes. Yeah, because your date, excuse me?
Rerun everything?
Okay, let me explain. So right now your data frame is not where it was when you started. So what that means is you would have to re-import your data, recreate DF because DF has been corrupted. Okay. So what you would, so in your case, what you would need to do is disconnect from your runtime. Okay. But before you do that, we want to verify that, yeah, actually, let's do this. So click on your runtime and click on and this is just for Maya, by the way, click on disconnect and delete runtime. And then what that's going to do, you're going to re-upload your family budget file.
Yep.
Okay. And then you're going to do runtime run all. And that should take you all the way down to the bottom and let me know if that works for you.
Okay. I'll just.
Let me know if that works for you, because that's in that case, and I'll just explain. So what happened with Maya is because her code was wrong, it actually corrupted the data for the date column to where it wasn't able to recognize it as date time anymore. So what we're doing is we're re-importing the data. We're disconnecting from our session, re-importing our data, and basically recreating our data frame. And that does happen, but that's why having a data set like the CSV file available allows us to do that. Okay. So Maya, were you able to do that?
Yes, I'm working on it. Yes,
Okay.
yes, I think it's I'm all the way. Everything looks good. Yes, it works. Date looks good. Yeah.
Yay. Awesome. Awesome. So it's not such a bad thing when that happens. So I'm glad that happened because we could talk about it. When that happens, and you could just have like a wrong character or something, but if it no longer sees it as a date, it's going to yell at you and say, well, I can't make it a date time because I don't even have enough data to work with. So that's why you were getting that error. And notice the errors are not very friendly. It's not like it makes it easy for you to figure out what's wrong. It's like all this stuff, right? All these lines, and you have to look at it to see. But I'm glad you were able to get that fixed. All right. So why don't, You're welcome. You're so welcome. So why don't we take a quick break? Because what we're going to do now, or next, I should say, is go into the storytelling part of the data analysis, which is so much fun, but it's hard work, but it's fun. So I want you to get some fresh, a pair of eyes, get some refreshment, walk around, do whatever you need to do. And I will see you back at, I'm going to say at 7. We have 10 minutes. Okay. You could just leave your computer the way it is. If we get disconnected, we will just rerun our code like we did before because we're pros at this. Okay. All right. I am going to pause our recording and I will see you shortly. I'll start our recording again. How's the pace for everybody? Are we going too fast, too slow? Just right?
That's right.
Just right? Okay. All right. Um, Good, good, good. If anyone gets stuck, you know what to do. Raise your hand. There's a lot of code here, a lot of things, but so far everyone has had the perfect errors because it helps us demonstrate what to do or why it happened. If everything went perfect, then we would not know what to do when something goes wrong or goes in a way that was not expected, right? So it's good that we have these things. This is how we learn. All right, I am going to share my screen again. All right, so this is where we ended off, right? Now, I'm going to guess that if everyone ran a DF code cell, they still have access to their data because it knows better than to kick us out, right? Is everyone still connected and all good?
Yeah.
Yes. All right. So now what we're going to do is we're going to jump down to our data analysis. What does the story tell, or what story does the data tell, rather, section. And we want to put a couple of code cells in that section. Okay. So what have we done thus far? We've done exploratory data analysis. We've done some pre-processing to clean up the data. And now we're actually going to do a variety of different techniques to aggregate the data and look at it in a different way. So one of the things that you tend to do is look at running totals. How many of you have ever heard of a running total for something? So, right. So from month to month, we want to see. So if I'm looking at January, I only see January and the total. Then when I do February, I see January and February combined. And then when I look at March, I see all three combined and so on. That's a running total. So I'm going to show you how to do that. I'm going to bring the code over. We're going to do a running total and create an actual data frame called running total table. And it's going to be basically a grouping using group by our current data frame. We're grouping by date and amount, and we're summing up by date the amount. We're summing those up, and we're creating an index called total. And then the next line is basically take that total and accumulate it using the date. So each month, basically, we're going to get a new value, as it were. So I'm going to, again, I just executed it so you can see what it should look like when you're done. Again, we're creating a new data frame called running total table. The beauty of this is we could graph it. We could do a bunch of things with it. So I'll let you type it and then we can explain what each line does. I'm also going to explain how you get insights from this table, by the way. Cumulative summing is done all the time, and it really, really helps with us understanding, especially when it comes to spending. the other thing I want to mention is anytime you see something on the right side of the equals, that's getting assigned to that which is on the left side of the equals. So we actually created a new data frame, running total table. And we know that because we've done that a couple times tonight. And that's a very, very powerful technique, by the way. Everyone getting it okay? So there's a lot of parentheses and there's a lot of square brackets. There's no curly braces in this one. But once everyone's done, I'm going to explain line by line what it's doing. All right, this first line is basically creating the data frame. And the data frame is comprised of a grouping by date and amount, right? So date and amount, getting a sum of the amount, and naming a new column called total. So think of it as for every change in date, right? Take the amount and add it to the prior amount. So it's a monthly total is what it is. And we reset the index to introduce a new column called total because we didn't have that before. And that's this second one here, this second column. Okay, that's what the first line is doing. Everyone good so far? The second line is, again, using the data frame that we created, it's adding a column called running total, and it is equal to the cumulative sum of total. So running total for the first iteration is equal to the total because it's the first month of the year, right? When we get to the second month, which is February, it takes that total of February and adds it to the prior, and the running total is 94.52.50, right? And it keeps doing that. Then it sorts the values by date because we want to see from month to month how things transpired. Okay. So what's really cool is we can say, well, how much did we spend in the first quarter of the year? We know right away it's $14,285.
Very cool.
Right? By the end of June, right, which would have been, you know, the starting of by the end of June, we have spent $33,340. And for the whole year, we spent $68,621.75. Notice this is an array, so it starts at 0 and ends at 11, 12 months, 0 to 11. Okay. How cool is that, right? So what else, what other observations can we make just looking at this? What do you see? What do you notice?
May is a high amount of spending.
Now, is it May or is it June?
Oh, wait, June, sorry.
Ah, excellent. So we see that in June, things jumped, right? Interesting. We see another jump. Where do we see another jump?
November.
November. Ah, so we see that in the summer, like in June, and in November, we've got a big increase. And so,
And for sure in this
Right. So then we would ask ourselves, and assuming you were sitting there with your husband, wife, partner, and saying, "Well, what happened in June? What did we do in June? Oh, yeah, we built a deck and put it on the house. Remember all that lumber? Oh, right. Or what happened in November? Well, we went. It was holiday. We went for Thanksgiving. We flew out to wherever. Right. So that's where you start looking at it, saying, ah, that's the reason. So now we know which months we had an increase in our spending, more than we normally do, just by looking at it this way. Now, this is good to see it this way, but it also would be great to see a beautiful chart, wouldn't it? Because, hey, if you got accused of spending money, you have to prove yourself why. You're going to have a pretty chart to do it, right? So the next chunk of code I'm going to give you is scary, but it's going to create a pretty chart. So it's worth every penny. All right. So we're going to go down to the data visualization. Now I don't need these other two cells. So let me go ahead and get rid of them because we're not going to use them. I did this for a reason. What data does the story tell? This is answering that one question, right? Was there like a pattern or seasonality or months where we spent more than we intended, da da da. That's basically what that told us. Now what we're going to do is we're going to bring a cell underneath the data visualization section. We're going to bring a cell and I'm going to show you some code. Again, you're going to type it very carefully. But by me pasting in, it gives you time to type it. We want to visualize our expenses over time. And the way that we do that is we're going to use the data frame that we created, the running total table, to build a chart. Now, I'm going to run this to show you what it looks like. How pretty. Look at that. Let me move this out of the way. Yeah. And guess what? It shows a different color for the larger months. You see? So that's what we want. We want to have a nice, pretty chart. So I'm going to go back up to the code and let you see it so you can type it. All right. Now you'll notice there's commas and there's certain indentations and stuff. You want to type it exactly as you see it. Because this way you know what the X value is, the Y value, and the color and the title and so on. And I'm going to explain to you in the chart what line of code generated what. By the way, too, when you get down here, this is y-axis and this is x-axis, just so you know. So a chart has an x-axis and a y-axis. So that's what that's referring to. This, by the way, is using Plotly. It's a library that gives you the fancy charts. Matplotlib is kind of plain, right? It gives you charts. This gives you nice charts. So when you see it refer to PX, that's our call to Plotly Express or PX. Now you'll notice we're calling for a bar chart. These are bars, right? There's different styles of charts. This happens to lend itself very well to the data that we have. We want on the x-axis our dates, which in this case is our months, and on the y-axis our running total in thousands. We want the totals to be color. So the color, or what another chart library is the hue, it'll vary the hue based on the total. And then of course the title of the chart is running total. And what also is cool is when you mouse over any one of the bars, it tells you what date, the running total, and the total. How cool is that? It has a nice little hover. When you hover over one of the bars, it shows you the actual information instead of having data labels printed on it. So it's an interactive chart as well. Everyone okay with that code? Getting there? Now, anytime you have an interactive chart, so for example, I can mouse over and see all the data labels. Keep in mind that if you're planning on printing this chart and putting it, let's say in a PDF or something, the ability to hover over that chart is lost in the printed form. So if you're going to be putting this in like a static kind of printed format, you know, the mouse over is really going to be not so appreciated, right? So you would do this for an interactive chart that, let's say, people are going to view on screen, because that gives them the ability to hover over and see the different data points. So if you were printing them out, you would choose a different way of providing the data labels. You would put it right on the bars, which is a different style of chart. It's still a bar chart, but a different format. All right. Anyone still doing the chart? Anyone having trouble? Everyone have pretty bars?
No.
Not yet? You will,
No.
I promise. You will,
Not
I promise.
yet.
You will. You'll have pretty bars. I'm going to move this out of the way. It will look like this. It will, I promise. We will wait for everybody, so no worries, no worries. We all type at different speeds, and that's okay. Remember, it's not how fast you type, it's the quality of your typing. So there's no racing in coding, right? No race.
All of the inputs. Let's see. Oh, yeah.
All right. We have some completed on Zoom. Anyone still typing? Yes, no, maybe? You ready for me to explain what each line is doing?
Yes.
All right. So we created, if you remember, we created this running total table, right? And now we're going to use that to visualize the data differently. We don't want to see it just in a table. We actually want to see a nice chart that gives us more perspective, right? So what we did is say, create a chart and assign to, or create a variable rather, I should say, it's a variable for our chart. And it's going to be a Plotly Express, that's the PX bar chart. The data source that we're using is running total table. And on the x-axis is the date, and on the y-axis is running total. So if you look here, we've got x-axis is the date. We've got dates here, right? And running totals on the y-axis. And notice these are the dollar amounts in thousands, right, that we spent. So date is on X, dollar amounts on Y. Then the color is going to be represented by looking at the totals. And when the totals vary a lot, it knows automatically to color the outliers. How cool is that?
Mhm.
So yellow for the June, and actually November into December. December is where it really went up really high, like almost $2,000 more. So December and June were our outlier months. Remember our question, which months do we spend extra? We can't figure it out. We just spend, we don't remember, right? Well, this tells us visually, whereas this table, not so much, right? Not so much. But you can see that there was a $2,000 difference between November and December. So we knew, just looking at the dollar amounts, that yes, it was. But how do you convey that to someone visually? Not everybody can understand mentally, what's $2,000 difference, but we can see it on the chart. So if you were communicating this information to someone, this is very helpful. Now, the title is running total. That's this right here. And then what's really cool is we can update our X and Y axes to have labels. And that's what these labels are on the X and the Y axis. So month, people would understand. They would see the year and say, oh, it was 2020 and the month. So we update the X axis and we also show tick labels, and we make sure that everything is visible on the X and Y. So our titles is visible and our tick labels is true. Now, what are tick labels? Well, that's these guys. That's these guys, okay? And it's very helpful for a chart where maybe they can't quite see across to see, oh, that's 60,000, but what did I spend in that month, right? Well, now if I mouse over, I can see exactly what I spent total. Now there's the running total, and there is the total for the month. How cool is that? Very informative to have it that way. And then, of course, we need to show the chart because we want to see all the prettiness. So we tell it to show it. Show us all the goodness. Pretty neat, right?
It's cool.
Yeah. So that style of chart is nice. Now that is a Plotly Express style chart. Okay. Um, Now we could do another chart and it's very similar to this one. So what we're going to do is we are going to create another table that gives us total expenses by month. Okay. Now you might be wondering, well, didn't we already do that? Well, yes and no. This one's a running total over time, right? What we're about to do is create another table. And so let me give you that code, and we're going to create another chart to give us one more bit of insight. Okay. So I'm going to scroll up here and just give you the code here. Hopefully everyone can see it. So we want a chart that shows us our monthly expenses without a running total. All right, it's very similar to the ones that you did before, but it has a very specific purpose. So we're building a total monthly expenses table using a group by on the amount. We're summing up the amount and we're creating a column called total. And we're then actually renaming our columns so that they make sense for us. So date will become month, total will become total expense. And there's that mapping again that we did earlier. Mapping is a very, very good skill to know in Python because it's often the case where you need to tell a variable or something to be called something else. And that's where you give it another name or what have you.
Oh, sorry.
And after this, we'll do one more chart and then we're going to conclude with the insights, which is really one of the most important parts of the analysis. What did we learn? What insights did we gain? These types of pivot tables are very easy to create in Python. But if you've done it in Excel, you'll see the similarities. In other words, the goal is the same. Usually involves some type of summation or totaling. And in some cases, you want to do a running total. Some cases you don't want to. In this case, we're summing by month. So we know monthly what our expenses were. And what I'm going to do is in a cell underneath, I'll put the code for the chart. And this way, if you get caught up, you can actually do that. And then we're going to talk about how to summate what we've done. Okay. Now this chart is very similar to what we did prior, but not identical. So Now, one of the trends over the class tonight is building tables, building cross tabulations, building charts from those cross tabulations. And in each case, we created a new data frame. So that's something to think about.
Not to mention
Yeah.
the cases.
We getting there? A lot of code, huh?
Yeah.
A lot of code. Now what's
Library will be closing in 30 minutes. Please come to the circulation desk at this time to obtain a library card or check out any material. Please note that there will be no more faxing. Computers shut down automatically 15 minutes before closing, and notice of absence will also be locked. Thank you.
Aha. So one of the things that you'll notice is as you build code over time, you want to remember that you can always reuse that code for other projects, other purposes. You want to think about that. So that's why we comment our code so we know what it does, and we know that, oh, I need to create another one of those types of charts. Well, let me just grab the code and tweak it. So we're not having to reinvent the wheel every time. So that's called using basically a programmer's toolbox. You have code, source code at your disposal that you can actually utilize for other purposes. And that's why we want to document our code very carefully to make sure that we know what it does and when we could actually reuse it. How's everyone doing okay? Getting there? Now, are a lot of you taking the Python classes during the week, and are they helpful for this? Yeah,
Yeah.
I would
Yeah.
definitely encourage you to continue that because it gives you practice. And I see everyone each week is doing much better. and maybe not as fearful of the code, right? So this
Right.
code's probably more complex than what you're used to, but you're able to grasp it because you've seen it over and over again. You're working with each month or each week, I should say, your knowledge grows, right? You're starting to remember, this is that. I remember typing these things. So it's a good thing. Maya, do you have a question?
No, thank you.
Okay, I saw your hand raised. I wasn't sure if that was from before. I don't want you to think I'm ignoring you. I see the hand. All right, so can I scroll down a little bit, or is everyone?
Oh, sorry,
No, yes?
no.
Okay. No worries, no worries. Now, for those of you that we did finish and did generate your chart, just get a feel for how that chart is different from the one that we did prior. They might look kind of the same, but they're not. So just get familiar with some of those differences. The other thing I wanted to mention while everyone is still working is anytime you see a group by and two fields, or you're grouping by date and amount, think of it this way. We're totaling up, we're summing up for each change in date and basically for each change in the group by value, which in this case is date, sum up the amount. So that's what that means. When you see group by and date and amount, it's the amount that's getting summed, but it's the grouping of the date, which gives us our month by month. All right. So that might be something to think about. I'm grouping by date. In this case, it's monthly expenses. And I'm summing up the amount. And you know that group by is very helpful. That's how we get those totals that we're looking for. And we all know what the sum function does because we've done it in Excel. So this is how we do that in Python. All right. Anyone still working on it? Yeah? No? Can I scroll and show the chart?
Yeah,
All right. Look at that. So this looks very similar to what we did before. How is it different? Who knows how it's different? We still have June and December, but what's different about this?
which month is it? It's not
We-
running.
It's not a running total. You got it. Exactly. So in some cases, you might need to just show the month by month situation, but not a running total. So that's what this does. And the other one is different in that it added in that running total. And that's why we had thousands on the side, a very high amount, right? Whereas this is basically month to month. But we can clearly see that June and December were huge months. So that's a question we can unequivocally answer here. Okay. All right. For the sake of time, we had a couple more charts to do, but we didn't get them done. So guess what homework is? So I want you to write down what the homework is. It's really quick. Okay. I want you to try, and next class we will look and see how well you did. You're going to be doing it in office hours as well. See if you can create an expense by category table and chart. So expenses by category. We did expenses by month, right? And we did expenses over time. Think if you can create an expenses by category table and corresponding chart. All right, so focus on category and also do one for description. So remember, category is a column in our data frame. Description is also a column. Try those two and see how well you do. Remember, you've got existing code that will help you, but you have to figure out how to tweak that code. And the way that we created this is we utilized tables to create the data frame that we built the chart on. Okay, make sense?
So you said expenses by category and then the other
Expenses
one.
by description.
Thank you.
You're welcome. You're welcome. So those are two. I have faith you can do it. You can do it. All right. You can do it.
Corresponding tables and charts for the description too.
Yes, you're going to create tables for that and then charts. Yep. Does that make sense? Do you have any questions on that?
No.
No? Okay. So everyone has their workbook, of course, saved in the cloud. It should say all changes saved at the top. And I'm going to go ahead and stop sharing. Any questions about anything we went over tonight? Again, the pace, it sounds like, was good for you. It wasn't too fast, too slow. Okay. All right. Good. Because that's the goal. I want you to feel comfortable. Once we get into the Airbnb data set, there's a lot of records there. And so I'm just making sure that you feel comfortable before we dive into that. And things of that nature. So it's okay that we take a couple weeks to do this because this will be very valuable moving forward. Okay. All right.
Great.
Any final announcements, Julia, before we go?
Python is ongoing if needed. Right?
Yeah.
Python on Wednesdays, one more class to me on Wednesday, next Wednesday. I hope it will help with Vincent. And all these classes are recorded and you can see it on the open tab. Okay.
Yeah.
So
Yep.
probably it's not clear for you our internal structure because we are actually now second class through the technology or through the data analytics course too. It's our internal numeric calculation. I don't know how to say it better. But yes, we are doing the second course, and right now we're for the class 2 of the second course. So we're just doing modules, right? 5 classes, 5 classes, 5 classes.
Yes.
So now we are in 2.2. Make sense?
Yep. Absolutely.
Calculation of mitigation for all these things. 3 more classes and you will be done with the exploratory data analysis. And then start group will be. And just see. You try to nail Python. You know, you're doing Python from with Dr. Cynthia right now, we do Python with Vincent. But actually from different perspectives, you are solidifying your Python. Simplifying, solidifying Python. If I more Python, will be here.
You're welcome. You're welcome.
Thank you.
Now.
You're welcome. Okay. I'll see you next week, folks.
Thank
Take
you.
care. Bye-bye, everyone.
Good night. Thank you.
Good night. You're
Bye.
welcome.
Good night, everybody.
Good night. Good night.